This is a particle podcast. WA Science told different. Powered by SciTech.
Please Look Up is recorded at SciTech on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we'll be discussing what you can see in the night sky in the month of April. My name is Leon, and I'm joined by Beth, a professional presenter from the SciTech Planetarium. Beth, thanks for being here. Do you want to tell us what's up in the night sky this month?
No, I don't, Leon. So, last month, we changed things up a little bit, and if you missed last month but are a regular listener of our wonderful podcasts here at SciTech, you'll know that normally one of us comes on and is asked lots of questions by Leon, but then we worked out that Leon actually knows way too much about space. So I'm going to ask him some questions about what's going on this time.
Fair enough.
So Leon, what's going on in the night sky?
You can sort of think of the night sky this month as a transition period. The brightest parts of the Milky Way galaxy are not really up there just yet, but also all of the planets are just in a real unfortunate position right now for us to see. So you've kind of got to go outside and make what you can with the stars that you can see. So a couple of notable constellations, if you're outside after sunset, maybe 8:30, 9 o'clock at night, if you look to the east, you'll see the well-known constellation of Leo, which is a what?
A what? It's a lion.
It's a lion, of course it
Leon?
is. Yes, that's exactly where the name comes from. And that's quite recognisable. It looks like an upside-down question mark of stars in the sky, because the sort of the curly part of the question mark is the lion's mane, because this is a sort of handover from a northern hemisphere constellation, whereas the other way around, it doesn't look upside down from where it's originally got its origins.
Yeah, so I had a question about that because in the UK, where I'm from, I have a trick for finding Leo, which is that I find Ursa Major, which looks like a saucepan, and it's full of beans, but you imagine the bottom of the saucepan's fallen out and the beans all fall on Leo's head.
There you go.
But it's a backwards question mark in the Northern Hemisphere.
Yeah.
But how, is there a trick to finding Leo in the night sky down here, or are we just...
It is quite distinct, yeah. The upside-down question mark really does... There's no other pattern, at least that I'm familiar with looking at, that really looks like it. And then just next to it, there is a triangular pattern of stars as well, which is actually the lion's back legs and tail. So it is quite a distinct constellation. It's a bit faint, but if you're looking for an upside-down question mark, it's kind of hard to miss. It's, as I said, in the eastern sky this month at about 8:30, 9 o'clock at night.
Awesome.
And yeah, unfortunately, we can't use your trick because we can't see Ursa Major from down here in Perth. If you go a little bit further up in the north of Western Australia, you can, sort of beyond Exmouth and beyond, you can see Ursa Major in the very far north, but not from down here in Perth. So, good trick though.
It's fun. It works in a different Perth.
Yes, that's right. the one in Scotland. Good point. And actually, just above Leo, there's another not a very well-known constellation, but it's very, very big. It's actually the largest constellation of Hydra, which is the snake. And it's kind of faint. You kind of should use an app to see it, because otherwise it's just a line of stars dotted across the sky. But it is there, and it's the largest constellation, and it sits above Leo in the sky. So once you've found Leo, just look above there and kind of imagine some stars, or kind of imagine a snake in the form of the stars that you will be able to see. And maybe use an app like Stellarium to help you find Hydra, the constellation. It's pretty cool.
And if Stellarium want to sponsor us at any point in time, that would be great.
I think they're a sponsor. It's a free app. I don't think they've got money to give away. As far as the planets are concerned, if you were to look at where Earth is from space right now, and then, so imagine you're in space and you're looking at Earth, and in the background is the sun, and then roughly along that line of sight, all of the planets are somewhere along similar lines of sight, meaning if you're looking at a planet, it shares a pretty close line of sight to the sun, which is another way of saying it's either out during the day or just before sunrise or just after sunset.
Right.
So yeah, all of the planets are in real bad positions right now to really get a good look at.
Right. So it's like if we were looking at the solar system from top down,
yes,
they're all pretty much in a straight line.
Yeah, it's a very generous version of a straight line, but
It's
more like a wedge.
a space straight line.
Yeah, space straight line. It's more like a wedge with
Cool.
a pointy bit at the Earth and
Right.
then encompassing the sun and beyond.
Yeah.
It's definitely not a planetary alignment, but they're all roughly in that same direction, in the same direction as the sun, which makes them very, very, very poor viewing. The only thing that's really worth going out and looking at is in the morning sky before sunrise. You will be able to see Mars and Saturn. They're very low on the horizon, but they are there. And Mars is, of course, it's just like a shade of red, and Saturn's there as well. And on April 11th, if you're out at 5 o'clock in the morning, they actually have a very, very close approach to within like half a degree of each other. So literally, the pinky, the width of your pinky separated on the sky.
Oh, wow. So if you're up really early in the morning and you see two very bright spots that are very close to each other, it's on the 11th, it's Mars and Saturn.
Yes, that's right.
Awesome. Oh, that's so cool.
Yeah, one of which is reddish.
Yes. I will not be up.
I will not be either. Now, if you are up later, if you're sort of a night owl, then from about 10 o'clock onwards, the brighter parts of the Milky Way start to show in the eastern sky, and you can tell that by looking for the constellation of Scorpius, which looks like a fish hook.
Yes,
obviously, it looks very different to the upside down question mark.
I was about to say it's a question mark and a fish hook, not a similar shape.
Yes, but they're distinct enough. But yeah, if you're out, that sort of marks the central regions of the Milky Way, which are brighter. But yeah, those are up later. Midnight's the best time to go out for that.
Yeah, awesome.
The only other real space news on the agenda is, and you probably can hear about this all over the social media, is of course there is the solar eclipse on the 8th of April.
Ooh, will we see it?
I was going to say, do you want to know how you can see it from Australia?
Yeah.
You can watch it on your TV.
No.
We can't see it from Australia.
No.
Not even at all. As a matter of fact, Perth might be almost exactly on the other side of the world for it, like the actual moment. So the eclipse is on the 8th of April in sort of Greenwich time or coordinated time, but because we're many hours ahead of the United States, it actually occurs at about 1 to 2 o'clock in the morning on the 9th of April in Perth time. So it's literally the middle of the night for us. We can't see it. It's on the other side of the world.
So it's happening in America, basically.
Yeah, that's right. So just to backtrack a bit, it's a solar eclipse. So this is where the moon passes in front of the sun. And
is that like the Exmouth one?
Yes, that's right.
Awesome.
So yeah, in fact, if you remember from exactly 1 year ago, April 2023.
We've lost a few years.
What happened
it's been to 2022?
In April 2023, when we had the eclipse in Exmouth last year, same type of eclipse where the moon passes in front of the sun and casts a shadow on the Earth. And it's a very, very narrow shadow. And so it's only visible, that shadow, that path of totality is only visible to a very small percentage of the world. But people who aren't directly in that shadow can often still see a partial solar eclipse. And yeah, the eclipse begins out over the Pacific Ocean, moves over Mexico, like the shadow, that's what I mean.
Yes.
As the moon moves across the face of the sun, the shadow that it casts moves across the face of the Earth, and that shadow starts in Mexico, moves across the United States, and finishes off passing out into Canada and over into the Atlantic Ocean.
Right, so we are in literally the worst place to watch this eclipse.
Yes, we are. But there will be...
We had our turn.
We've had our turn last year. There will be countless live streamers broadcasting it. And this one's actually a lot longer. So the eclipse we had in Exmouth last year was just under 1 minute, like the moment of totality when the shadow, when you're standing in the shadow. This one's actually going to last about 4 minutes for people over in the United States and Mexico and Canada who will be able to stand in that shadow.
What changes that? Like, what makes an eclipse a minute long versus 4 minutes long?
Yeah, excellent question. And it's the distance to the moon. The moon's distance to Earth is not quite constant. It doesn't orbit the Earth in a perfect circle. Sometimes it's closer to the Earth, and so it looks slightly bigger in our sky.
Yeah.
And sometimes it's further away from the Earth, and so it looks slightly smaller in our sky. And so eclipses happen because, as we said, the moon passes in front of the sun, but... And they're about the same size. However, if the moon's a bit further away and the moon's a little bit smaller, it still covers the sun. It still can cover the sun, but it doesn't have as much extra coverage as if the moon's much closer to Earth and bigger in the sky. So when we had the eclipse last year, the moon was a little bit further away than normal on its orbit. It was sort of towards its furthest point.
Yeah.
And that's why we had a very short eclipse, because the shadow was a bit smaller on Earth. Whereas here right now, the moon is much closer to Earth, closer to its perigee, as it's called. And as a result, it looks bigger in our sky, and so it can block out the sun for longer.
Oh, so what's the shortest and longest possible eclipses?
The longest possible eclipses can get up to about 7.5 minutes, I think.
Oh, wow.
Whereas the shortest ones are like less than maybe about 30 seconds altogether.
Oh, wow.
And
Okay.
Funny you should ask, because if you're wondering when's the next solar eclipse happening in Perth,
Yes, please.
the next total solar eclipse to happen in Perth is in the year 2068 on the 31st of May.
Is it going to be 30-second eclipse at
It's
that?
33 seconds long.
No! Oh, that's so long to wait.
That's the next one that passes directly over Perth, though. The next
Okay.
one visible from Australia is in 2028.
Oh, okay, that's
so
more
that's
reasonable.
not too bad. Yeah, in July 2028. So, but that one's it's not going to be total in Perth. It'll be you have to go up north to experience totality.
Oh,
But you will see it on social media. It's going to be all over
Yeah.
the news. Obviously America, big popular news.
yeah.
You'll see it.
Oh, just one thing that you were saying, when the sun and the moon are the same size, you mean like how they look in the sky?
Yes, 100%
Cool.
correct.
Yeah.
No, you're right.
Just double checking. I was like, I'm pretty sure they don't shrink.
No,
I'm pretty sure.
and it's a complete coincidence. There's no fundamental reason. It's just coincidence that they happen to look the same size. And you might have heard the factor of 400. So the sun is in real life 400 times wider than the moon, but it also happens to be 400 times further away than the moon. And
Right.
so those two factors of 400 cancel each other out perfectly to make them about the same appearance of size in our sky. But in real life, the sun is significantly larger.
So within our solar system, total solar eclipses are a pretty unique thing to Earth.
Yes, that's right.
Awesome.
There are eclipses on other planets, and there's some really, really beautiful photos of eclipses on Mars that have been taken
wow.
by the Mars rovers. But yeah, you can see a beautiful solar disk, and then in front of it there is one of the moons of Mars, but it's this oblong potato-shaped thing that only covers like 30% of the surface of the sun. So
Oh,
while
wow.
it is an eclipse, it's not a total solar eclipse.
Oh, well, that's really good to know, and also very disappointing that there won't be a total solar eclipse in Perth for
For a very long
another
time.
too many years for me to do maths in that quickly.
Yeah, just book your trip over to like Sydney in 2028. Book it now because eclipse chasers are already doing that.
Oh my goodness, are they?
Yeah, they book out years in advance, like
Oh,
the
wow.
hotels and things like that. But yeah, it will pass over Sydney. So
Oh.
yeah, Sydney gets its turn in 2028. Perth doesn't get
Fine.
its turn till 2068. Another 44 years. Something to look forward to.
Absolutely. So I think that's all of our space news for this month.
Yeah, those are the main updates.
Yeah, awesome. Thank you, Leon. So last month we introduced a new segment, and we called that segment Space Flight Focus. Although we didn't say it in that kind of voice, but I just thought I'd jazz it up a little bit.
I think it sounds good.
So Space Flight Focus is all about updates on space flights. It's very creatively named. Yeah.
Yes.
But last month we had a look at moon missions. And this month we've got something very exciting, right?
Yes, well, it happened in March, but yes, we'll make it the space flight focus of April. Yeah, we saw the third test flight of the SpaceX Starship, Ooh. Which was enormous news. And look, it's
enormous news?
Yes, it is. It's the current largest rocket ever launched, but it will eventually. It is intended to take people to the surface of the moon. So we're still kind of on track with last month.
Yeah, it's an update.
Yeah, but this is still very much a test flight. It's nowhere near ready to take people to the moon. But yeah, that was the big news. It was its third test flight. So it's called Starship, which I kind of mentioned. But it's interesting. The rocket comes in two halves. There's the sort of the bottom half of the rocket called the booster, and then the top half of the rocket is called Starship. But then the whole rocket stacked up like that is also called Starship. So the word Starship does double duty.
Right.
Yeah, so just keep that in mind.
Okay. So SpaceX's big thing is reusable rockets, right?
Yes.
So as far as my understanding goes, we've got the space shuttle, which is the one that we used to send astronauts to the International Space Station.
Yeah,
on.
and a couple of other specialised missions. But
Yeah.
low Earth orbit, yep.
Yeah, and that was a space shuttle which was put on rockets, but the rockets, once they're done, are just sort of jettisoned back to Earth, and aren't... They're single-use items.
The space shuttle boosters were.
Yes. So is that the same with the SpaceX rockets?
No. That was a proper Australian nah. No, so you're right. So SpaceX, they're pioneering the reusability. So what they're most well known for at the moment is the Falcon 9, which is their sort of workhorse rocket. That's a significantly smaller rocket, but they're the ones you've seen those spectacular videos of, where the rocket comes down and puts its engines on it just before it slams into the ground. It burns off its speed and it touches down perfectly. And so that is a similar style to what I just described. It's a two-stage rocket. You have the booster, and then you have the second stage. And the booster gets the rocket off the ground, or it gets the upper stage off the ground. And then after about 2 minutes, the booster is run out of fuel and separates. And then historically, every other rocket in history has then discarded the booster and dished it into the ocean or into an empty part of the landscape or something like that. Whereas SpaceX have developed the technology to actually save just a little bit of fuel on that booster and then carefully allow it to come back to Earth and turn the engines on just before it lands, and then save the booster. The upper stage still goes on to space, delivers its cargo of satellites or people, and then that later burns up in the atmosphere as space junk. So the upper stage is not recovered.
Right.
But the first stage is. That's the Falcon 9. Starship is like that, but significantly larger, and also with the intention of reusing that upper stage as well.
Oh, awesome.
And so it's 121 metres tall, which puts it 10 metres taller than the Saturn V that took people to the moon back in the days of the 1960s and 70s.
Wow.
So, I mean, how big is that? It's like, it's almost the size of a football ground.
Whoa, yeah, I can't even put that into context in my head.
120 metres. I actually worked it out once. 110 metres is the length of SciTech, so it's slightly longer than SciTech.
Wow, yeah.
That doesn't mean anything to anybody who doesn't work there or visit us regularly, but...
Well, I mean, I'm thinking about it from a slightly different nerdy context, which is I know how impressive the Saturn V Lego model is.
Yeah.
Like, that's a big piece of Lego.
Yeah.
So I'm just imagining an even bigger Lego model that I'm hoping is going to be my Christmas present soon.
One of these days it will be. Basically, SpaceX has been developing Starship for a few years now, but it's only in the last year have they started doing these test flights of the full stack, as it's called. This was the third test flight. Interestingly, the first test flight was on the same day we had our eclipse in April last year. And that one...
steal our thunder.
Yeah, I know. So I went and watched the eclipse and then went home and watched the launch. It was a great day. But the first flight had a lot of problems. It got off the ground. But what was supposed to happen is when the bottom stage runs out of fuel, the second stage is supposed to separate and take off.
Yep.
But it just completely failed and spun out of control and the whole thing blew up. Yeah. But they did another test flight in November of last year. They separated successfully, and the second stage kept going. It almost made its way to space. The first stage blew up pretty quickly after that. So they separated. The first stage blew up, and then the second stage it got almost all the way to space. And then they're like, it wasn't carrying any cargo. It was a test flight, so they had extra fuel. If it was carrying a cargo, it would have burned up its fuel to carry that cargo. Yeah. But because of that, they dumped the fuel and oxygen overboard, and pure oxygen is extremely flammable.
Yeah.
And so when they did that pure oxygen caught fire, and then
the
Starship blew up after that. So third time's the charm.
I mean, to be fair, that second time sounds like human error rather than mechanical.
There are a couple of other errors too, but this one, third time's the charm, and it went pretty well. They launched, stage separation was successful. The booster, they were trying to bring the booster back like they do with the Falcon 9. It got most of the way back, but spun out of control at the last minute, and it exploded for reasons we're still not quite sure about. But the second stage made it all the way to space.
That's awesome.
And they were trying to do a number of tests on it while it was in space, but they're including like trying to move fuel around, like pump fuel to different parts of the spacecraft, trying to open the pod bay doors so that one day when they have cargo on board, they can open up the doors and throw out the satellites and things like that. There's mixed reviews on how successful those tests were. But then the big one, which provided some really spectacular images, was they were trying to re-enter to prove this is, they're trying to, as I said, they're trying to reuse both parts of the spacecraft.
Yes.
And the only way to do that is to bring your spacecraft back from space.
Yeah.
And the space shuttle, it's covered in those tiles, those black tiles that are the heat shield.
Yeah.
And But yeah, they're extremely complex, but SpaceX has got the same sort of idea. They've half the Starship is covered in tiles, and they attempted re-entry, but if you go back and watch the video, the spacecraft is kind of tumbling out of control, and it just hits the atmosphere at all the wrong angles. The heat shield tiles don't do the right thing, and eventually it just burns up. And and that was off the coast of Western Australia, actually, because even though it launched from Texas in the United States, its orbit took it halfway around the world, and then it was going to re-enter, and it was never intended to be recovered. It was just going to splash down in the Indian Ocean. But yeah, it didn't splash down. It just burnt up.
So did it burn up thoroughly, or could I go beachcombing and maybe find some bits of spaceship?
It was a big spacecraft, so but it kind of depends on what the tides and the currents are doing. The Indian Ocean currents are very susceptible, very sensitive to the monsoonal seasons in the near the equator, and I'm not quite sure what phase they're in, whether they're pushing stuff this way or the other way, like towards Western Australia or towards Africa.
But maybe keep an eye out.
Maybe keep an eye out if you're on the northwest coast of Western Australia.
Oh, that's good to know.
Yeah, I don't know if we'll have another piece of junk washing up like we had in Greenhead, maybe a year or so ago.
That was a piece of I remember it being on the news as like mystery space junk washes up on Australian beach. Is it still a mystery?
I don't know if it's part of an Indian rocket, but that makes sense, doesn't it?
Yeah. So with the SpaceX mission, are we expecting it to be ready for cargo anytime soon then, if they're on test number 3, but it's still kind of exploded a lot?
I reckon they'll be doing cargo within this year. That's my forecast. Probably not like commercial or government cargo, but their own stuff. So SpaceX, you might know, are building a group of satellites called Starlink, which gives you internet all over the world. And the next generation of Starlink uses very, very large satellites. They can only be launched on Starship because they're
too big for the Falcon.
Yeah, that's right. So they're launching other Starlink satellites on the Falcon right now. But I reckon we'll eventually start to see within this year we'll start to see cargo on board some of these ones.
That would be so cool.
Yeah, if you're into high-speed internet in remote areas.
I'm into high-speed internet anywhere that I am. That would be great.
Fun fact, when we were up in Exmouth for the eclipse last year.
Did you go to the eclipse?
Yes, I did.
It's nearly like you never speak about it, Leon.
I know, yeah. We live streamed that, and we were using a connection from Starlink.
Oh,
so there you go.
It's kind of full circle.
It is, isn't
Starlink, it? Do you know if no, you said the test run on that day was empty, wasn't it?
Yeah, that's right.
And it would be so cool if they'd launched a Starlink on the day that you were using Starlink.
Yeah, they might have on the Falcon. I don't think so. It's interesting the way the door is built. It's like the Starlink satellites are designed to stack one on top of each other, and then the door is only a very narrow door, and then it pushes them out, and then the next one comes down. So it's like a Pez dispenser.
Oh, that's so cool.
It's even nicknamed that in the astronomy community.
Oh my goodness, that's amazing.
So, but still inconclusive. So
very expensive Pez dispenser.
Yes,
and very expensive Pez to go in.
True, but if you just some quick numbers. So currently, a Falcon can launch about 15 to 20 tons of cargo into orbit for about $100 million. Starship can launch 150 tons, so literally almost 10 times as much. And it doesn't cost 10 times as much. It's kind of unclear what Starship's cost is at the moment, but it's not $1 billion per launch.
No.
Or it won't be when it's ready to go. So
that's brilliant.
So when you do cost per kilogram, it will be significantly cheaper.
Buying in bulk.
Yeah,
it's
buying in
the
bulk.
Economic thing to do.
That's what it is, yeah. This is 100% buying in bulk. So that's the space flight this month.
So another segment is Space Picture of the Month, our most podcast suitable, very audio friendly segment. So Leon and I have both once again found a space picture of some description that we are going to send each other to describe for you guys and then work out what's going on. So
I'm just going to spoil this in advance. I've got a trio of pictures only because it tells a story.
Well then.
But they're not 3 different pictures. They are all 3 related pictures.
Okay. I have one picture.
Yep.
As the homework decreed that we should have. Thanks, Leon.
Sorry.
Making me look bad. I've sent my one picture.
Ooh, okay. I've never seen this picture before, by the way.
No, I've not told Leon anything about this picture. You have seen this picture before, but I have not shown you this picture before in this context.
We haven't discussed it like this. What a beautiful picture. This is I have seen this picture before. It is one of my favorite pictures.
Me too. That's why I picked it.
Let me describe it for you. It's Saturn, firstly. So it's an image of Saturn, and the whole planet is in view, and you can see the rings there, and it's taken from a distance, but it's got this almost ghostly glow to it. Firstly, in one of the outer rings, it's a very, very, very thin ring that is sort of ghostly glowing, and then the whole planet has this sort of strange illumination going on, almost as though the sun is directly behind Saturn at the time, and I describe it as almost as though the sun is directly behind Saturn, because I know for a fact that it is directly behind Saturn when this photo was taken.
Is Saturn backlit?
That's the word I was looking for, backlit. It's backlit by the sun, and it's one of the most incredible photos ever. Beth, tell me, why have you brought this here today?
So I picked this photo because it's one of those pictures that, I don't know, it might not be a photo. Is it composite?
I believe, yes, it's a composite.
Yeah. So this was made up of a series of images taken by Cassini, the spacecraft mission that we sent out to have a little poke around Saturn and its rings. And I love this photo because we're all in it. I mean, well, some listeners might not be if they're very young, but the Earth is, I'm going to say visible in inverted commas, because if you do zoom in very, very closely, you can see in the background of this image a tiny little light. It's just sort of a glowing dot in the background, and it's not a star, it's us, it's planet Earth, which means that this picture is a picture of every human who had ever lived up to that point.
So yeah, anybody born before July 2013, or anybody who was alive on Earth at that time, is in this photo.
Is in this photo. But even everyone who existed on Earth before that as well, because it's a photo of Earth, and no one's gone anywhere from here yet.
Yeah, true.
Yeah. So yeah, I think it's beautiful and awe-inspiring and exciting. Like, one, it's just a gorgeous picture, but two, it's that, like, look, there we are, just little us. And I know it was a thing in the UK. We were all encouraged to go outside and wave at the time, because I think it was actually at a reasonable time of day for Britain that, like, we knew Cassini was going to be looking back at Earth. We knew when the flyby was going to be, so it was like, hey, everyone, go outside, wave at Cassini.
Yeah, right.
So yeah, I thought that, I think it's very, very touching, because a lot of our images of space as well, we lose the human. Like, space feels very sci-fi and futuristic, and I feel like we can often lose sight of humanity, but at the same time, I feel like space flight and space exploration is one of the most human things that we do. Like, we want to explore and know more and discover, and it takes huge amounts of teamwork and innovation to do so. And so I like that this image just sort of reminds us of the humanity in space.
Yeah, absolutely. And it of course brings back, draws comparisons to the pale blue dot.
Yeah.
Which was a similar picture of the Earth from even further away, taken by the Voyager spacecraft in the late 80s, I believe. And then, it prompted Carl Sagan to famously quote about, this pale blue dot upon which we so fragilely exist.
Yeah.
It is a nice reminder of the humanity, isn't it?
Yeah. And so I thought I'd bring it back to that a little bit.
That is nice. Well, thank you, Beth. What a beautiful picture.
Yeah.
I'll send you my picture now. And,
your 3 pictures.
My 3 pictures. We'll start with one, because speaking of a human connection.
So my first point about this picture I've been sent is that it's not a picture of space. I mean, it is of the atmosphere, but it is daytime from planet Earth, I assume, from context clues, taken out over the ocean. There's a lovely sort of cloudy sky behind it, a little bit of sunset. And when I say behind it is a sort of shiny white statue of a man in boardies with a unicorn floaty?
That's a pretty good description, yeah.
What? What is going on, Leon?
Yeah, so but that's a pretty good description. It's a statue of a man in board shorts with a floaty around his waist and a unicorn sticking out of it.
But like a ceramic floaty by the looks of it.
Yeah, so this is from Sculptures by the Sea, which I'm guessing you might not have gone and looked at.
Not this year. I have previously gone to Sculptures by the Sea, but I did not see this year's, no.
There you go. So it's a statue there that's part of it now. Down at Cottesloe Beach, and I think I'll just invite you to look at the next picture.
Yes.
Why have I picked that? And the reason I picked that is, of course, I imagine many people listening might have gone and looked at Sculptures by the Sea. It's become a bit of a cultural thing here in Perth.
Now, Leon, the next picture that you've sent me does nothing to explain why there is a sculpture of a man in floaties. But what I've got now is, I think, an aerial photo. And it's got a lot of vertical lines, mostly straight, but some, slightly chevron in angle, with different years, I'm going to assume, because I think the earliest I can see is 1988, and then I can see a 2021, 2022, 2005, 2003, and they're all different colours.
Yes, that's right. So what we're looking at is an aerial view of the beach right in front of where that sculpture of the man with his unicorn floaty is. And those lines are showing the position of the shore as it changes over time. So as the ocean advances on land and the beach erodes, or as sand is deposited there and the beach can sometimes actually extend further out.
Yeah, so because this is not in exactly the order you might expect, because I know a lot of the time, we're hearing about climate change and rising water levels and rising sea levels, but this is showing rising and falling. So the 1988 line is quite far inland, and it does definitely seem to decrease into the 2000s, like as in the sea level.
The shore
decreases.
Yeah, that's right. There's more sand.
Yeah,
and the waves are the wave kind of retreats.
Yeah, but then it comes back again up into 2021 and 2022. Is the sea level is now higher than it was in the 80s.
Yeah, that's right. The water is advancing more on the land now than it was 20 years ago. Yes, and that's exactly what the data is showing. And so finally, I invite you to zoom out. To picture number 3. It's just a zoomed out version I've just described.
Yes. So this time we have an aerial image of the whole of Perth. We've also got Rottnest Island off to the side, I think. And along the coast are lots and lots and lots of little data points with meterages next to them. So the one near Cottesloe says 1 metre plus or minus 0.4.
Yeah, that's right. And so this is showing the variation in the position of the shore as it currently stands. So based on the last year of data and so on. But yeah, you saw in that previous picture we had much finer resolution on a year by year by year.
Yes,
and you can see some of these shores are advancing, and some are sort of they're coloured blue, and some of them are receding, where the shoreline is getting eroded away, and they're coloured in red. And you can see dotted up and down the coast. Different parts of the beach are advancing and different parts are receding. The reason I've brought all of these photos here is all of this data has actually been done for all of Australia. There's a really good website that I got this from. So you can look at the coastline and what's happening everywhere. But it's all based on data collected from a series of United States satellites called Landsat. And Landsat is an ongoing program since the 1970s. It's a series of satellites. There's 9 of them up there now, and they just orbit the Earth at a low altitude, and they just take photos of the ground, and they've been doing it since the 1970s, and they collect data in multiple different wavelengths, and a lot of that information is made publicly and freely available for partners of the United States, of which includes Australia.
Oh, wow.
And so the Geoscience Australia, which is handles the partnership with the US Geological Survey, has produced this study of Australia's coastline mapped off the Landsat data, and it's because it's been collected since the 1970s. They were able to track the shoreline of Australia over since the 1970s and see which parts are receding, which parts are growing. And so you can imagine if you've got this receding shoreline that might affect houses and suburbs and businesses within the next 20, 30 years, that now is the time to start acting on this data.
So maybe if you're out and about scanning the Australian coastline for parts of a spaceship, you could also maybe do some involvement in local bio restoration methods.
Yeah, why not?
There you go.
Or even
Best
if you're
of both
just
worlds.
out catching sculptures by the sea, you can just remember that beach can change, or does change over time.
It does.
The reason I brought this up as well is that Australia has just signed on to be part of the next generation of Landsat with the United States.
Oh, good.
Landsat Next is what it's called. It's going to be 3 more satellites launching by about 2030, and Australia actually already has infrastructure that supports Landsat. There's a receiving dish out in Alice Springs that collects data from the satellites.
Oh, great.
And it gets pipelined to to Canberra, where it gets processed and stored there. And Australia has just committed $200 million to maintaining, upgrading those facilities.
Oh, great.
To support these next 3 Landsat satellites. And, this is just one example, looking at, the variation of beaches on Australia. That's a very specific study, but, there's all sorts of things you can get out of this. So the bushfires in Australia.
I was about to ask, because it's just aerial photography.
Yes.
Then, I can imagine, is it infrared as well? You said multiple wavelengths, so we could just see a heat map of Australia from this as well?
Correct, yes. So, that's right. Anything you can imagine doing, infrared and visible is what it has. So the stuff that our eyes can see and the stuff that a heat camera can see.
Yeah.
Yes, that's right. So bushfires are a great example of that, or even just hot spots.
Yeah, surely warm weather fronts as well, weather patterns you might be able to see a bit, how the land warms and cools at different times of day. Yeah,
definitely. So that's good for farming, for example.
Yeah.
Also, infrared can give you information about moisture content in the ground. So if you've got thousands of hectares of farmland, this part's really dry, this part's really wet, you can direct your watering.
Yeah, your irrigation, you can control it a bit better.
That's right, so you're not wasting
brilliant.
water, or you can see, if growths within the soil are creating hotspots, like fungal outbreaks are giving off different signatures. You can track crop health from space. Bushfires give off smoke, which is easily visible, and you can also see where forests are. So if you have a bushfire and there's a forest here and there's a empty land over there, you can then allocate resources for where that bushfire is likely to move.
Awesome.
So it's of enormous financial and economic benefit to Australia. Because committing $200 million sounds like on a receiver and some computers, but the economic output for this is well worth the input from Australia.
So finally, we are going to come to our last segment, which is Constellation of the Month.
Constellation of the Month.
So this month we're going to be talking about the constellation Puppis.
Puppis, yes.
I am always disappointed is not one of the dog ones.
No, it is not. It does not stand for puppy or puppa or any of the names for a dog. I thought maybe you might like to tell me about this constellation, Beth.
So last month we were talking about Carina, which is one of the Argo Navis trio, and Puppis is another. And I don't know, you might have picked up from last time, one of the things that I'm quite a fan of is language and how that has sort of evolved. And I'm pretty sure that Puppis comes from the poop deck, which is part of a boat, which the Argo Navis trio is. But that's also interesting in itself where poop deck comes from, because people think that when it's a boat and they hear poop deck, they think, oh, is that where the toilet is? No, the toilet is called the head on a boat.
There you go. So Puppis is up in the sky this month. It's in the western sky after sunset, and once again, one should use an app to find it.
Yeah, I think if you can find the Southern Cross though, it's between the Southern Cross and Orion.
Yes, that's right.
Yeah.
Like Carina, halfway between Southern Cross and Orion.
Yeah, it's just a bit further over.
Yeah, exactly. But I would recommend using an app because it's a bit harder to make out. It's not really an obvious one.
It's not got a distinct shape like Leo or the Southern Cross or Orion.
No, that's right. And once you know what you're looking for, you can kind of look at it and go, oh, yeah, I can see how those pattern of stars can be interpreted as a boat.
Yeah.
And, there's the back of it, the la poupe. But it's a bit harder to make out. Now, interestingly, when stars are named, the one way of naming stars is to name them in order of brightness using the Greek alphabet.
Yeah. So like Alpha Centauri, Beta Centauri. So Alpha would be the brightest.
Yeah, and so on. It's just that when that naming system was applied to the Argo Navis, which was once one big constellation, a lot of the stars in Puppis are quite faint. So the brightest star was called Zeta, which is... but that was using the naming system applied to the whole Argo Navis.
Right.
But when the constellation of the Argo Navis was broken up into Carina and Puppis,
Because otherwise it was just too
it was
big.
just too big. Yeah, they didn't redo the naming system, so all of the old names of the stars still apply. So now the brightest star in Puppis is called Zeta Puppis.
Oh.
Yeah, which is I think it was a name of, it was like the sunken cost fallacy.
Yes, yeah.
Yeah,
We're not renaming all of these.
Yeah, too many research articles about using the old naming convention.
The brightest one is still the earliest in the alphabet.
It would be, yeah.
Yeah, it's just
It's
like starting at P rather than starting at A.
But also Q might be in another constellation, so the next one in here might be S or T or something like that.
Right, yeah. But the order still works. You just might be missing a couple letters on the way.
Yeah, exactly. And Zeta Puppis itself is an extraordinary star. It's about 55 times heavier than the Sun, which means it undergoes hydrogen fusion in its core way faster than the Sun, and as a result it's way hotter, way brighter. And
so you said it's heavier. Is it bigger?
It is bigger, yes.
Okay.
It's
I know that matters with stars, because sometimes stars can be heavier, but they're just way more dense, right? So they're a similar size, but they've got more mass.
Yeah. This one, it's bigger and heavier, but it hasn't started to swell like some of the other stars.
Right.
So there are stars that are less heavy, but actually bigger than this star. This one's only about 20 times bigger than the Sun.
Okay.
Only.
Only 20 times bigger.
Because, yeah, it's still what's called a main sequence star. It's still fusing hydrogen in its core, which is very, very deep inside the star, obviously.
Yeah, so it's not it's not like a red giant.
No, it's not yet. Yeah. But because it's so furiously burning fuel, it gives off total about 500,000 times as much energy as the Sun. But because it's so hot, most of that energy is actually in ultraviolet. So ironically, it doesn't look as bright as some of the other stars either, because we can't see ultraviolet.
Right.
So
if
it's still,
you had a UV camera and pointed it up at that part of the sky,
it'd stick out like a sore thumb.
Awesome.
Yes. Fortunately, UV it's not very good at penetrating Earth's atmosphere.
Okay, so we'd have to have a UV camera in space.
Yes, so something like the Hubble telescope, for example.
Oh, well, that would be convenient, wouldn't it?
It does a little bit of UV, not deep UV.
What about James Webb? Is that...
No, James Webb goes the other side. So UV is very high energy beyond what our eyes can see, whereas James Webb is low energy below what our eyes can see.
Right.
But yeah, Hubble sort of does what our eyes can see, but just peeks into the UV.
A little bit either side.
Yeah, a little bit either side.
Okay.
But yeah, it's an extraordinary star. But yeah, it's ironically both very bright and somewhat faint, but it's still the brightest star in the constellation. It's it can't make up its mind.
Yeah. I mean, I feel like that's partly our fault and our definition of bright when it comes to stars.
Yes. The other cool thing to mention in the constellation of Puppis is the Rotten Egg Nebula.
The what?
Yes. Its fancy name is the Calabash Nebula. I'm not sure where that name comes from.
It's a tropical American tree with large melon-like fruit.
Oh, I didn't know that.
Neither did I.
maybe it, I don't know, I'm going to show you the picture of the calabash.
Oh. No, that's the same shape as the fruit.
Oh, there you go.
Look at the fruit. The fruit is long and green, and it looks like a sort of pale, chunky zucchini.
Right, there you go. Well, this picture, yeah, I guess so. It's kind of elongated.
Yeah, it's like a big long oval.
I realise we've already described our pictures, but
we can do more pictures.
Doesn't matter. The Calabash Nebula, it's a dying star. So it's a star that as it's ceasing fusion, it's thrown off its outer layers, and rather than throwing them off spherically, it's thrown them off elongatedly. So that's why it looks kind of like a zucchini. But in doing so, it's also exposed a lot of its inner elements that were closer to the core and have undergone fusion. And in its lifetime, it's fused a lot of sulfur. And so the nebula is full of sulfur, which is the same chemical that gives rotten eggs their sort of nasty smell.
Oh, so that's why it's the rotten egg nebula.
Not the visuals. Yeah, not the visuals. The visuals give it the zucchini appearance.
Yeah. Oh, that's fun. I do like when scientists remind the rest of the world that they have a sense of humour.
Yes.
And I feel like the Rotten Egg Nebula is a good example of that.
Spot on. But yeah, so Puppis is visible in the western sky this month.
And where within Puppis is the Rotten Egg Nebula? Like, is it near... Did you say it's near Zeta Puppis, or...?
I can't remember.
What do you mean you don't have an encyclopedic knowledge and precise knowledge of the entire universe at any second that I might choose to ask you any random question out of my brain, Leon?
I like to cultivate the reputation that I do, but clearly you've found a gap in it.
Well, that is awesome, though. I will definitely be going and looking up, and I will be telling people about the nebula that looks like a zucchini but smells like rotten eggs.
I think it's a perfect way to end it.
Well, thank you, Leon. Thanks so much for having me on the podcast again.
Oh, thank you for being here, Beth. It's been a time and a half. And that's it for this episode of Particles Please Look Up. We'll see you next month, where we talk about the night sky and the space news for May. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.